In this video, we'll learn about some of the most key operations that we'll perform on data frames in Python, in Pandas. So let's look at an example here. So first thing is, let's understand how to read and write CSV files and XLS files. Though since you might already know what CSV is, it's basically comma separated values. CSV stands for comma separated values. We have seen these examples earlier in file.io and things like that. Suppose if I have the data like this, what it does is it stores the date first, let's say 1/1/2017. The second value is 32, so it will separate values with comma 6, rain, right? That's how it will store this row. The second row will be stored in the next line in the file with 1 to 2017, 35, 7, and sunny. This is how your CSV files are organized. On the other hand, XLS files are nothing but your Excel files, your Microsoft Excel files. Anybody who has ever used a Microsoft Excel looks like this. Okay, this is how Microsoft Excel looks like. Microsoft Excel is a very, very popular software which is used extensively, by the way. So this is Microsoft Excel here, and wherein you can organize your data into a table. This is as part of your MS Office package. This comes as part of your MS Office package. So Excel files are oftentimes used to store data in a table, to store data in tables. That's what Excel is. That's what, and they have typically .xls or .xlsx. Okay, these are the extensions that these files typically have. And as I told you, Excel files. So these are Excel files which are part of Microsoft Office suite of software. Now, lot of people either store the data in CSV or Excel. And by the way, you might think, okay, Excel is something that I learned as a kid. Why do I really care? A lot of data analysts and a lot of even machine learning folks, even I like to use Excel to do simple data analysis in a tabular format because it's very visual sometimes. Okay, now let's look how to read data from a CSV file. It's very, very simple. So in this folder, I have some data. Let me show you the data here. I have weatherdata.csv. Let me just open this data for you. I'm just trying to open it with a text editor. So this is how my weatherdata.csv looks like. So I have the column names, day, temperature, wind speed, and event, and each row is separated. Each row has values separated by commas, as you can see here. That's the data I have in weatherdata.csv. Now how do I load the data? It's very, very simple. You just import pandas, and pandas has read_csv. This creates a data frame like this. Now this is basically called the index of the data frame. This is called the index. Okay, and you have your date column, temperature column, wind speed column, and event column. It looks like a table, right? So that's what read CSV does. It loads data from a CSV file and puts it into a data frame. Now to do the same thing with Excel, you'll have to do a slight hack. So you'll have to install a package called XLRD. So you can install this by just saying pip3 install XLRD. XLRD is a package which helps you load Excel files. Okay, again, it's very, very simple. You say pd.readExcel and you give the name of the Excel file. Now let's open this Excel file and see how it looks. Now I'm just going to my Excel file here. So this Excel file is called, let me look at the code, weatherdata.xlsx, right? So, let's go to our Excel file. This is what the Excel file looks like. Now, if you notice, the Excel file has basically, again, rows and columns. The name of this file is weather_data, and the extension is .xlsx. The more recent versions of Excel has .xlsx. The older forms have .xls extension, file name extensions. Okay, these are your file name extensions. These are your file name extensions for Excel files. Now, as you will notice, this can be loaded using Microsoft Excel, and that's what we're doing here. Now let's go and see, let's go back to our code here. And of course, I can simply load the data again using read_Excel. I just have to give the name of the Excel file. And it loads the data exactly as you expect, right? See, earlier we had read_CSV for CSV files, and here we have read_Excel. It's literally one line of code to load data. Now, if you want to store data, to a CSV file, how do you do it? So imagine if I have my data in a data frame. Let's assume the data frame in which I have data is df. I can just say df.toCSV and I can give the name of the CSV file. Right? When I do this, it stores the data in the new CSV. Let's open the new CSV file here and see how it looks. right? Just a second. Okay, this is how the new CSV file looks like. Okay, if you notice, there is a subtle difference here. In addition to all of this data, it's also storing the index here. If you notice here, this is my new.csv, right? Which I created using df.tocsv, right? And I said new.csv. This is the command that I executed. Now, when I execute this, in addition to all the data, it also stores the index as the first column, right? Index basically is the row number here in this case, right? We'll come to indexes and understand what indexes are a little later in this video, right? Along with your day, temperature, everything, there is this additional data, which is your index. Now, if you don't want the index to be stored, it's also very, very simple. Let's go back here. Now, if I say df.tocsv, I'm giving a new file name called new noindex.csv, and I'm saying index equals to false. When I say this, now let's see how is this file stored. This file name is new underscore noindex.csv. Now let's open that file and see how it looks like. So new underscore, okay, this is where it is, right? If you notice, this is the new underscore csv, so new.csv. This is new no index. So when I said index equals to false, that's the new argument that I passed, right, to this whole function. When I do that, if you notice, there is no index here. There is no index here. When I did not have that, there is index here, right? This is how you store your data into CSV file. If you want the index to be stored, you can store it like this. If you do not want the index, you can just say index equals to false. Very, very simple stuff. Nothing very fancy here. Okay. Similarly, you can store your data into Excel file. And to store data into Excel files, you have to install this package called Open Python Excel. So this is open because it's open source. Py stands for Python. Okay. Open because it's open source. Excel basically stands for Excel. So this is a very interesting package in Python which helps you store data to Excel files. And all I have to do is I have to say df.toExcel. Just like toCSV, I just have to do toExcel, give the name of the file. And in Excel, there's something called a sheet name. I'll show you what a sheet name is, right? In an Excel file, I can have multiple sheets. I'll show you what a sheet is in a little while. But remember, the sheet name is weather underscore data. Now let's go to Excel and see this. Okay, this is not the file. Sorry, let's open. Okay, this is the file, right? So it's basically new.excelSX. As you can see the name here, it's new.excelSX. And if you notice, let me move this up slightly. Now what you'll notice here is this is called the sheet name, because in an Excel file, I can have multiple sheets like this. This is called the sheet name, right? And if you look at our code, we said the sheet name is weather underscore data, right? So the name of the file, a file can have a single Excel file. A single Excel file contains multiple sheets, and a sheet is nothing but a table. A single table is a sheet. So I can create more sheets here, right? That's a terminology that is used in Excel, right? Now let's go back, and I'll also move my tool a little down here, right? It was actually blocking this name, and hence I had to move it. But otherwise, now we are back to track, right? So here, if you recall, it's called new.excelSX, and the name of the sheet is weather underscore data. Okay. Now we understood how to store data and how to read data from both CSV files and XLS files. Now let's go and understand other very interesting and important operators on data frames. There is an operator called group by. Let me show how it works with an example. So imagine that I have all of my data for various cities stored in weather's data cities.csv, right? What I have here is I have the day, I have the city of New York, I have the city of Mumbai, I have the city of Paris, etc. For each city, I have temperature, wind speed, and if there was an event like rain, fog, sunny, snow, etc. Okay, this is my table. And as you can see, all of this data is in a CSV file, which I'm loading, right? And all of this data is in my data frame DF. Now let's see if you want to perform some interesting operations. Now when I say df.group by city, so this is the key function here. It's called the group by function. So if I say df.group by city, what it does internally is it groups all of these rows, whether they're ordered or not, it doesn't matter. So because I'm saying group by city, that the column name I want to group by is city. So what it does is it takes all of these rows where the city name is the same, right? Like Paris, and it puts them into a group. So it takes all of these rows, it puts them into a group. So those of you who have studied SQL and databases will understand the group by command, right? There is a group by command in SQL and database. That is exactly what it's doing. Now we'll see why it is useful in a little while. Okay, let's see what types of problems it can solve. Now once I'm storing the group by information in a variable called G, and now I can say for city comma city df in G, I can print the city and city data frame, right? So what it's literally doing is in a group, what I have is in a group for each city, I have a new data frame, right? So if I say for city comma city data frame, when I print this, what happens is I get the city name Mumbai, and this is the data frame corresponding to this city. So this is the name of the city, and this is the data frame corresponding to that city. If you notice, name of the city is New York, and it's only New York data, right? And one other thing is, if you take Paris, this is the name of the city, and this is the data frame corresponding to that city. But remember, when I'm creating these data frames, I have my indices intact, because look at what are the indexes of Mumbai, right? For Mumbai, I have indices 4, 5, 6, 7, right? The first column, as I told you, is the index. You can think of it as a row number. I mean, that's not the exact interpretation of it, but index basically lets you directly go to a specific row if you want, right? You can brutally think of it as a row number. There is a subtle difference between index and a row number that we will learn at the end of this video. But for now, you can just simply think of it as row number. Now, when I do group by, those row numbers are, so these indexes. So for example, this is a new data frame, right? This is a new data frame. This data frame corresponds to the city of Mumbai. But if you look at the row, if you look at the indices, these are the indexes. Okay, these are the indices, or you can call it, actually the plural of index is indices, not indexes. So if you take the indices of this data frame, they don't correspond to row numbers, because this is row 0, this is row 1, this is row 2, this is row 3. But the indexes have been copied, or the indices have been copied from the original data frame, right? This is a simple case where the index or the index is not same as row number. Anyway, as I promised you, we'll see this a little later. Okay, but I just wanted to bring this up to you. Now comes the interesting part. Now if I say g.getGroup New York, right, then what I can get is I can just get the data corresponding to just New York, right? If I say g.getGroup Mumbai, I'll get just the data, or the data frame corresponding to just Mumbai. But here is the more interesting thing. Imagine if I want to find the maximum temperature in each of the cities, or maximum wind speed, for example. Then all I have to say is print g.max. When I do that, what happens is for each of the cities, the temperature and wind speed, which are numerical attributes, I get the maximum value. The maximum value of temperature in Mumbai is 92. By the way, these are Fahrenheit and not centigrade. 100 degrees centigrade is almost 92 degrees centigrade is close to boiling point of water. Nobody can live in the temperature. Okay, so these are Fahrenheit. These are not centigrades, just to be clear there. Okay, and you have your, so here what I've got here by just using g.max, because I've already grouped this data for Mumbai. In that group, it will compute the maximum temperature and the maximum wind speed, right? If I want the average values, right, because average can only be computed for numerical attributes for each of the cities. If I just say g.mean, it gives me the average temperature and the average wind speed for each of these cities, because G is already a group. G is the output of the group by command, right? So for each of the elements, for each of the subgroups here, it will do this computation. Similarly, I can use g.describe, where it will give me some interesting information. For example, for temperature, so for Mumbai city, there are 4 values, and the mean value is this, the standard deviation, minimum, the 25th, 50th, 75th percentile, and max. Those of you who do not understand what is standard deviation or 25th, 50th, and 75th percentile, check out our videos on exploratory data analysis, where we explain what standard deviation is, what mean is, and what these percentiles actually mean. Similarly, for wind speed also, which is a numerical attribute, because we are using a describe function here, it gives us all of this information, right? So group by is a very, very useful command when you want to treat something in groups of things. Very, very useful. We use it extensively in machine learning and data science. Now let's look at understanding how to concatenate or how to join of sorts data frames. Okay, now here I'm creating a simple data frame. The data frame looks like this, and I'm creating using a hash table, right? So because this is a dictionary or hash table or a dictionary. Okay, dictionary is a very Python specific term, but in data structures it's called a hash map typically. So this is a very, very common term in Java. If those of you who know Java collections will know what a hash map is, right? But in Python it's a dictionary. So I'm creating a data frame using a dictionary where I'm saying the city names that I have are Mumbai, Delhi, Bangalore. My temperatures are 32, 45, 30. My humidity is 80, 60, 78. So when I do that, right, I get this type of data frame, right? And this data frame's name is India weather. Similarly, I am creating another data frame called US weather, right? Where I have cities of New York, Chicago, Orlando, and I'm just creating these three. I have the same three columns. I have the columns of city, humidity, and temperature here, right? Here I have city, humidity, temperature, even for India weather. Now, if I say pandas.concat is a very useful function. So if I want to concatenate the data, if I want to create one data frame where I have the data of both, India and US in a single data frame, how do I do it? I just say concat, and within a list, I basically say India weather, US weather. Now it will put all the India weather data here and the US weather, US cities data here. Now if you notice the indices, it is simply copying the indexes or the indices, because in the India weather data frame, these are the indices of these three rows, right? And in the US weather data frame, this is also a data frame, right? So when I just do concat, the indexes from the base data frames is simply copied, right? Now here I can make a small modification if I want all of them to be ordered, right? If I don't want this confusion here, if I want all of them to be ordered properly by row number, all I have to say is ignore index equals to true. It's just the same thing. I'm using concat. I'm putting these two values in a list, right? I'm putting both of them in a list. All I'm saying is ignore index equals to true. Then if you look at the indexes here, they're exactly the row numbers, which means when you say ignore index, it's what you're doing here is you're ignoring the indexes or the indices that we have for each of the individual base data frames, the India weather here and the US weather here, right? Now here, if you recall, what we have done is we have two data frames which we combined like this, right? But what if, so this is my data frame for India and this is my data frame for the US. This is how we combine to create a bigger data frame. What if I want to create a data frame like this, right? Column wise, I want to concatenate them like this. My df1, my df2. If I want to concatenate them like this, not row wise, but column wise. Okay, or I should call it the other way. So you can think of them as common column names here. If I do not want that, if I want to do a row wise concatenation, right? All you have to do is, it's very, very simple. You just use the same concat command and you just say access equals to 1. Now what happens is, for each of these three values, now it says city, humidity, temperature, the first index, whatever it is. So Mumbai's data and New York City's data. Similarly, Delhi's data and Chicago's data, and Bangalore's data and Orlando's data, right? So here, what have we done? We have constructed the larger data frame by concatenating them on the rows, not on the columns. Okay, so this is called concatenation. Now there are more interesting operations called merging. So merging is sort of like, if you've ever studied SQL or databases, if you have not studied, it's perfectly okay, because I'll show you what merging does. This is like a join command that you might be aware of in SQL and databases. So merge here is sort of like a join command in SQL and databases. Those of you who have never studied SQL and databases, it's okay. I'll simply explain it to you, right? Here again, I'm creating a simple data frame called temperature data frame, where for each of the cities I have temperature. Okay, this is my temperature data frame. This is my temperature data frame. Similarly, I'm also creating a humidity data frame, right? So this is my temperature data frame for the same cities, right? Here I have Mumbai, Delhi, Bangalore, Hyderabad. Here I have Delhi, Mumbai, Bangalore. I don't have Hyderabad here. Okay. By the way, those of you who do not know, these are some of the most popular and largest cities in India. So when I have these, so what I have here is I have Mumbai, Delhi, Bangalore, Hyderabad. I have names of 4 cities here with the temperature. three of those cities, I have the humidity value. That's my second data frame. And this data frame is called humidity data frame. Now let's look at it. Now I can say this command called merge. Okay. If I say pd.merge, and if I give it two data frames, my temperature data frame and humidity data frame, and I want to merge it based on city. So this is the column name. The column name is city, right? So what it does is, now it looks at both the data frames that we have. If you look at it, we have a data frame which is temperature data frame, right? And we have a humidity data frame, right? We had a humidity data frame, and we had city name and temperature here, right? We had two columns here, right? Similarly here we had city and humidity, right? So what it does is, for the city of Mumbai, it looks at the temperature is 32, and again in this table it looks at where is Mumbai here. Need not be this first row. We could have Delhi here, we could have Delhi here, and Delhi could have been here. Delhi had 45 and 68, and Mumbai has 65. So what it does is, it first looks at the first value here. Now it says this is Mumbai and it has a temperature of 32. And now it says where is Mumbai in this second table. So it says Mumbai is here. So it says now let's combine these two tables. Now let's combine these two rows, Mumbai 32 and Mumbai 65, and create a new row here, which is Mumbai 32 65. Right? So this operation is called the join operation in SQL, where I'm joining two tables using the city name. Right? Similarly, now I look for Delhi here. Delhi, now I say where is Delhi, because I'm combining by city name here, right? I say where is Delhi here, or Delhi is here. So Delhi has 45, here Delhi has 68. So now it will combine both of them and say Delhi's temperature is 45 and humidity is 68. Similarly, Bangalore. Now here there is a problem. If you look at both of our tables, we have temperature value for Hyderabad here, right? In the temperature data frame, but in the humidity data frame, we don't have Hyderabad. We do not have, there is no Hyderabad here, right? So hence what happens is, when you do pd.merge, what happens is, since Hyderabad is not here in the second table, it will completely drop Hyderabad. So in the final result, there is no Hyderabad, right? Because between your two tables here, there is Hyderabad here with some value. Okay, let's assume, let's look it up. What is the value for Hyderabad? Hyderabad is 40, right? So, okay, Hyderabad is 40, right? Here I don't have Hyderabad. So when it tries to join, it doesn't find Hyderabad here, and it says, oh, I don't have the humidity value here. This is the temperature value. This is the city. Again, this is the city, and this is the humidity. It says I don't have this data at all. So it will completely drop this, and there is no Hyderabad in the result. Now, if you want Hyderabad also in the result, all you have to do is something called as an outer join. And the only change from the previous function is how equals to outer. How basically means how do you want to join them. When you do this, what it says is, it says there is no value for Hyderabad in the humidity table. So I'll just say not a number. But this value doesn't exist. But I'll copy the data that I have for temperature. So this is called an outer join. Those of you who have studied SQL, this is exactly equivalent to an outer join. Right? Join is basically all about merging tables based on some column name. So if I have a column name city here and city here, I can merge these two tables, and that merging operation is called joins. And we have seen simple join and an outer join. So this is called an inner join actually. So in database literature, this type of join where you drop if it's not available in one table is called an inner join. There are many other types of joins in databases, but I'll not go into it right now. There is another very interesting idea called indexing. Now let's understand indexing, because I've been talking to you about indexing a lot. Right? Whenever you create a data frame, let's say I have columns. I have column 1, I have column 2 and column 3. Right? It also creates an index column. It also creates an index column, and by default the index numbers. So this is called the index column. Okay, it automatically creates for any given data frame, it creates an index column, and the default indexing is same as the row number. The row number is the default index. The row number is the default index. But you can write your own index and say, I don't want to use the default index, I want any other index. Right? So for example, if I want to create a data frame with these values, I have these values, right? And I want the indexes to be this instead of the row numbers. Right? So when I do that, what happens is I get a data frame like this. So for example, imagine if I just ran the same command. Let me run the same command without the index, okay? So that you understand what's happening. Okay, so when I create this, look at it. I get all of these values, and if you notice my index numbers, so this is my actual data, one column of data, and this is my index. And if you notice, the index numbers are same as this is row 0, row 1, row 2, similarly row 9, right? But this is the default indexing. Now, if I want to give my own indexing, because it has its own applications, we'll see that later when we see how indexes are very useful for some custom solutions. Okay, but you can create your own index. You can say I want the one value to be at index 49, I want 2 to be at value 48, I want 3 to be at index 47. Whatever index value you want to give, you can give that. Now let me run this command for you and see what it creates. Right, it creates a data frame with this, and this is the actual data frame. These are the actual values of one column of data, and these are now your indexes. These are now your indices. And see, one, I wanted to have it at an index, and I want to give it an index value of 49. Similarly, I want to give it a value of 48. Now the question is, I want to access this data in two ways. This is my data frame, right? I want to be able to access and say, I want the data frame value corresponding to index 46. Okay, I want to know what is the value stored at index 46. Or that's one way. That's one way I want to index this data. Second way is I want to say in data frame, I want to find what is the value at row. This is row 0, row 1, row 2, and row 3. I want to find what is the value that is stored at row 3. There are two ways of indexing, right? One is using the index itself, right? If you have not given your own custom index, then row number is exactly equal to the index. But if you provided a custom index of your own, right? Because here, if you notice, we provided our own custom index, right? And we have this now. So now if I want to use my own custom index, now what happens is there are two ways I want to access this data. One way I can say is I want data in row number 3, or I can say I want data in index 46. Now they're two different things, right? Now how do we get the data, right? So let's see. There are two commands here called lock and ilock. Lock stands for location and ilock stands for indexed location. So we'll see what it means. Okay, so if I say silock, okay, let's look at it. So I said I want 46, right? If I say silock 46, let me execute it and see, right? So not ilock, slock. So slock 46, what does it mean? It means go to the index value 46 and get me the value that is stored here. So here I'm using the index. This is the index, right? I'm using index to access data, not row number. I'm not using the row number. That is very important, right? So when you're using lock, you're going to use the index. Now when I use ilock, what happens? Okay, so if I want, so my 46 is on 4th row, right? 0, 1, 2, 3, right? So row number 3. So if I say ilock 3, what happens? I get the same value. Okay, I get the same value of 4, right? Exactly as we expected. So what ilock does is interesting. Ilock basically says, I will give you the index by row number, while as lock says, I will find the value using the index that you have given. There's a subtle difference here. Now, for example, let's see what will happen if I say slock 45. Okay, slock 45. So it says, okay, the 45th value is here, so the corresponding value is 5. So it will return that value. But if I say silock 45, there are not 45 rows here, right? There are only 10 rows, because the row number for this is 0, the row number for this is 1, 2, 3, so on and so forth. I think there are 10 rows here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So if I say s.ilock 45, right? There is no 45th row, so it will give you an error. So this will give you an error. This will result in an error. But if I say s.lock 45, now what it says is, okay, it looks at the indices and says, oh, there is 45 index here. The corresponding value is 5. So this will return 5. So that's the difference between ilock and lock. There is one more difference. Now if I say s.lock, okay, I want to get all of the rows till index 2, right? Now when I execute this, what happens is I get all the values. So it now goes line by line till the time it finds index 2. It will get all of these values now, right? Same thing if I do s.ilock 2, what happens? Because ilock uses row numbers, right? I only get the first two rows. I literally get only the first two rows, right? So that's a difference. In a nutshell, while indexing, you have to remember that if you're using .lock, right, .lock function versus .ilock function, .lock uses the index, where ilock uses the row number. By default, if you have not given your own custom index like this, if you have not given your own this is custom index, right? I'm giving an index of my own choice. By default, your index is nothing but your row number. In such a case, your ilock and lock will behave exactly the same. But if you've given your own custom index, like in this case, right, because this is row 0, but my index is 49. That's what I mean by custom index. In such a case, there is a difference in output between lock and ilock. This is very important. A lot of people get confused between lock and ilock, especially when accessing data in a data frame. So be careful when you use lock versus ilock.